and welcome back to my 100th video. Yes indeed, and today we're going to be looking at a couple of more light-hearted projects, because Arduino is not all about hard work, is it? So let's have a look at these couple of things on my desk. First of all, we're going to be looking at this, so that's the first thing we're going to find out about, and the second thing is this red box at the back, which I think it was sold as a useless box or useless project, can't remember now, but in fact it's anything but, so you'll have to continue to watch the video to find out why. Okay, well obviously in order to build this I originally had to have it in various bits. It came in a kit, very cheap kit. So that was some time ago when I did it. In fact, I'd forgotten entirely that I hadn't done this introduction. So this is doing the introduction some days, if not weeks, after I'd done this and that. But that's what happens in the video world. Well, you never notice it with Star Wars, do you? Why should you notice it here? Okay, let's get on with the first bit of the project then. All about this. It's a Tesla coil. Very useful to learn about. But is it useful for us Arduinites? Right, so this is how the box turned up, so let's have a look what's inside it. It's a bit odd doing the video sort of back to front where the end result appears before I've even unboxed it. Right, there's obviously a heat sink, and in here, that's the coil itself. I have actually been reading up about Tesla coils, quite interesting little things. I won't take off the protection of that just yet. And what else we got? We got a bit of bent wire, not sure what that's for yet, and okay, some hardware bits. So we got a switch, and what else we got in there? Some kind of, is that a power? Can't tell. We'll go through the bits in a bit more detail. Just hardware basically, more packaging, and the circuit board. Oh, and neon. I wonder if that's to test it with. So we can just hold it near it and it'll work. Well, we'll soon find out, won't we? Well, it looks pretty simple, doesn't it? There's not a lot to it really. So we got that one transistor, the switch. Is that the power cable? No touch. Yes, it's probably worth mentioning at this point that this does generate some ridiculously high voltages. So yeah, don't give this to a kid for, you know, Christmas or something as a Boxing Day project. Probably not a good idea, no. Okay, well, that's it then. Well, I thought it was going to be a bit of a longer video than that, really. Well, let's get some of these components out and see exactly what's in there, apart from that one transistor. Don't worry, I'll cut this bit out. Right, there we are. A few bits falling on my workbench. So we have this, which if I put it up really close to the video it just goes even more blurred. I'll tell you what this is. I'm going to look off camera and let you know. Right, so this is in fact a BD243C. I still can't get that on there. Okay, anyway, all it is an NPN power transistor really. Allow a lot of amps through it, which in itself should be a warning, the fact we've got to put so much power through that coil via this. Yeah, it's going to create quite a few bits, isn't it? Okay, resistor, an LED that already goes inside, make it look pretty. Oh yes, there's the power socket. Switch. Yeah, switch on off. No touch, but you've got a switch right on the board. And what's that? Little tiny capacitor and various bits of hardware. Okay, that's it. Let's put it all together and see what it looks like. Well, I was supposed to do a recording today, but as you can see, Benny's taken over and he's explaining a few things on my my desk here. So, yeah, I'm afraid recording is suspended until further notice. Sorry about that, but Benny comes first, don't you, baby? Yes. All right, see you in a little bit. Well, construction didn't take that long actually, even though I didn't realise this, but there were no instructions with the actual circuit itself, so I had to look at the pictures to find out how to do this thing here, this red coil. And then I reversed engineered the circuit from the rather simple board and came up with this. And I thought, That doesn't look right. I mean, I've absolutely no idea why the coil here is attached to the base, the secondary coil that is. But I did a Google scan of Tesla coil circuits, simple ones, and that is exactly what they are. Exactly the same as that. Okay, whatever. Now, okay, we've built it. It runs off 12 volts. I've got 12 volts on the pack at the back here. Let's see what happens when I switch it on here. Actually, there's a little on-off switch. Now, it does this do not touch. Whether it's because this gets very hot, or whether because this is lethal, I don't think it is actually, but I wouldn't give it to a child, this kit. I'm not sure. So let's turn it on. And there you see that sparky thing at the top. Now, that's generating ozone like mad, but that's not the point of it. What we're generating here, in this sort of area that I'm generally showing you, is a huge electromagnetic field. And they do say keep your mobile phones away. Of course, my video camera is only about a foot away. Not even that. Half a foot. Hope that's going to be okay. Anyway, they give you this as a demo. And look, as we bring it close to the coil, it does actually glow. Not the best of all possible. Oh, that's interesting. My hand prevents the field reaching the bulb. That's interesting, isn't it? You would have thought a magnetic field of some kind would go through skin. But the frequency of this is several megahertz. In fact, let me just show you a very quick capture of what this field looks like on the oscilloscope in the workshop. I can't do it with my little JYE. Well, you'll see why in just a second. So I'm just going to take the oscilloscope probe, just like this, without grounding the other end at all. We don't need to clip this onto anywhere. And I'm just going to hold it near that field and right, turn it on. So here it goes. And as you can see, straight away, look, you get this lovely sine wave. Now if we turn on the measuring on the oscilloscope, right, so there it's measured, and as you can see, if you look down the bottom here, that the frequency 3.125 megahertz, all thereabout, with a duty cycle of 50%. So it's a lovely sine wave, and as I move the probe closer, it gets bigger, and as I move it away, it gets smaller, as you'd expect. Well, not a lot more to say about that, really. That is it. So there we are. A field of 3 megahertz, or thereabouts, a nice sine wave, and that's what causes this bulb, which they give you in the kit, by the way, to glow. Now, they also show you that these fluorescent bulbs, household bulbs these are, these are the compact fluorescent ones, look, they glow as well. That's actually not bad. And when I put this next to it, what would you expect to happen? That amperage to go up or down? Let's have a look. Well, if you're watching that, that's the current. So that's with the bulb fairly bright now, but take it away, no difference at all. Does that mean we're getting electricity for free? No, it doesn't. What it means is that this is generating the field regardless of what you're doing here. It's a bit like a radio transmitter. A radio transmitter can be generating, say, 500 watts of power, whether anybody's listening or not. It doesn't go up and down depending on how many radio sets are tuned in, and that's basically the principle of this. In fact, let's talk about the principle of the Tesla coil, because having now made it, I only bought it because it was a really cheap kit actually off Banggood or AliExpress or somewhere. I was just fascinated by it. Having bought it though, I'm not convinced of its practical value. Let's just go over to the browser. Now, this article here, which I'll put at the bottom of this video, it's how a Tesla coil works. But basically, as you probably know, if you know anything about transformers and things, it's basically a loose coupling on this one between this red ring and the very long tube here. Well, very long, a few centimeters, which is the bit you probably can't make easily at home. I mean, you could if you bought the enamelled copper wire, but it cost you probably more than what it's worth. The rest of the bits are very easily. When you think about this circuit again, look, I mean, there's just not a lot to it, is there? Now, admittedly, this isn't a very high-powered one, but even so, what's it all about with a Tesla coil? Well, apparently, there are some practical applications, as it shows you here, and I'll put this on the on the video description as well. What Nikola Tesla, let's get his Nikola Tesla, that's his name. There's a Wikipedia article all about him. He was a bit of a character, it's got to be said, apparently. I mean, he was still around in about 1937, was it? Let's just have a quick look on here. When did he pass away? 43, so, you know, he's not an ancient person, he is fairly modern. What they're saying is that he was that borderline between genius and crazy scientist, really, because, yes, this works, and what he was trying to do was to transmit electricity without wires. This half proves it. I don't know if it purely proves it or not. Yes, this lights up, but I couldn't run my radio from this. Although I suppose if I had a coil and put it near it, then it would work. But of course, then we are pretty much like a transformer, aren't we? However, if you made a big enough one of these, and he made absolutely huge ones, I mean outside ones, huge, like a modern day pylon to transmit electricity, then if you're in that field, you might well be able to pick up electricity, or I don't know, did you generate it or receive it? Don't know. It's one of those weird, crazy ideas that was never forwarded much in his lifetime. It's only been fairly recently that the work of Tesla has been taken on board. Anyway, I'll put those links down the bottom, but the main question remains. Can I smell? I'm not sure if I can smell burning. Let's turn this off just for a second. I bet this is hot now. Youch, that is hot, yes. Well, it was taking quite a bit of current, wasn't it? Incidentally, when you build this, if you ever do build one of these, you'll notice there's some sort of white goo around the back of this transistor. That is heat transfer paste. What do they call it? Compound, heatsink compound. You only need a tiny splidge. Now, don't start putting golf balls amount behind it. It's just to fill in the microscopic indentations behind the transistor and the heatsink to transfer the heat efficiently. Certainly, you wouldn't want to put nothing behind it. That would be very poor conductivity. What I'd normally use is a double-sided adhesive heat transfer mechanism. It's like a double-sided sticky tape. Let me go and show you it. So the thermal strip that I use, or like to use in preference, is this stuff here. Now this is it's sandwiched between two plastic sheets that you just sort of peel off, and as you can see, you can cut it to size. It's been hacked about at the end there, but it means you can cut it to exactly the size you want. But on this case, as I say, I couldn't do it because the transistor was already too close to the heatsink. So I've in fact used this, which is heatsink compound and is effectively a toothpaste type consistency compared to this, which is just like a bit of squidgy plastic, I suppose you'd call it, really, but it soon melts down when the heat gets onto it. And that's it. That's the difference between the two types of heat compound. So there we are. That's what I'd normally use for heat sinks, but on this one, because it's all aligned with the PCB, I couldn't fit it behind, so I've just used some standard heatsink compound, just the same as you'd use on a microprocessor in your computer, for example. Anyway, apart from the construction, which is fairly okay, you have to glue this tube to here, and they got some very fine wires. As you can see, that wire there is very fine, one end of which is sort of up here, and one end is secured underneath. Can't remember where it is now. There. Oh yes, there's an LED down the bottom as well. However, the main problem, having built this, and as fascinating as it is, let's turn it on and be fascinated some more, that it can glow this little neon. Now what? I'm thinking, how can we use this in an Arduino situation? I can't think of any. Literally, I've racked my brains. I thought, apart from switching the thing on and off, which you could do from anything, what possible use is there with this product? Pretty useless, I'd say, really. As a principle for learning about Tesla coils, you know, physics, bit of electronics, great. And yes, you can look through all these articles and they'll mean something and you'll learn. But apart from that, I'm thinking from an Arduino perspective, there's not a lot we can learn from this, and not a lot we can put into practical use anyway. So it's just as well then, given that that's sort of the end of the video at this point, or would be normally, I have another project. Now this project doesn't pretend to be anything other than a useless project. It even says that was the name of it. So let me show you that. Right, the decks are cleared, and this is the pretty useless project. I mean, you might have seen these before, either on YouTube or just on Banggood or AliExpress or somewhere. In fact, let me just get that up and I'll show you what that looks like. Right, here it is. As it says, it's a useless box. Makes no bones about it. It's a useless box, and it's a little toy that might make you smile. But there is a more serious side to this. Obviously, I'd like to get it involved with Arduino world somehow. This will be a good proving ground. And what I'll do is build this one up, show you it, see what it does. Okay, it makes you smile, but I think even then you'll think, can we add value using an Arduino, even with this useless box project? So this is the kit of parts. Let's unload those. I mean, admittedly, this kit is going to be mainly mechanical, but as I say, I don't think it's quite as useless as the title might imply. So we've got a battery box, we've got some kind of, looks like a solenoid there, we have a switch, and we have this strangely shaped piece of plastic, and well, they give you a spanner, and a screwdriver and a few nuts and bolts. To be quite honest, I'm thinking when I was a kid, actually, I was suddenly given a Christmas present of some Meccano. Meccano, for those who don't know what it is, it's pieces of shaped metal and painted sometimes with lots of nuts and bolts, and you can make all sorts of things with it, like cranes and cars and well, all sorts of things. And it's a grown-up boys version of Lego, I suppose you say, but it's made out of metal. I don't even know they still make it. I'll be surprised or disappointed if they didn't, because it really did push me along the way for sort of making stuff, you know, like this. So anyway, yeah, this would be a good kit for a kid, really. I mean, I'd say 12 years, perhaps. Can't remember now how old I was when I got my Meccano, but anyway, yeah, it looks all right. Now, this is the case. You can get this in two colours. So the brown you see is in fact protective paper. So you peel that off infuriatingly slowly. That won't come off anyway, so I'm not going to try. But that's just protective paper, and these then clip together as if by magic through the fact they're all laser cut. It provides a little box. Well, I'm going to put all this together now, and when it's done, we'll just see how useless it is and see if we can make it more useful. Well, from an Arduinite point of view anyway. Alright. And 2 hours later, or thereabouts, it certainly feels like it, we get to this position. So, was it easy just to put this together? Yeah, it was easy enough. It's a bit fiddly. You have to watch these little nuts and bolts that they actually poke through the side here, otherwise they don't quite pull the whole thing together. If you notice, all it's doing is sort of clamping it together, and you've got to get the orientation of this base plate correct, trying to follow that. So it's easy to get this upside down. Please don't ask me how I know that. Anyway, so that's the useless box. If you shut the lid, and there's only one switch, let's face it, I mean there's not a lot that can go wrong with it. So you switch it, yeah, that's it, end of. Should I do that again? That was a bit fast, wasn't it? You can see why it's a useless box though, because it does absolutely nothing except switch itself off. Let me film this in slow motion. Now I'm going to, that's it, so I'm going to push this. That is quick. Right, hopefully I'll have got that in slow motion. So all it does is have a little finger come out, if you like, on that solenoid motor. There it is, look. So there's a little motor in there, there's a little micro switch down the bottom. So when you turn this on, it just comes and switches itself off again. Now, as an Arduino person, you're probably already thinking of improvements to this, as did I, which is why I bought it really. So yeah, I mean, first of all, for example, there could be a delay on here. It's far too quick, isn't it? From the minute you touch that, it's done it. So there could be a delay. What else could we do? Well, there's lots of things actually. What I'm thinking of is this switch that we can probably see inside there. Look, it's all mounted on that board there. I reckon we can probably take a closer look at that and intercept what that switch is doing. So basically disconnect it from that board, because I'm hoping it's sort of a simple on-off switch, but whatever it is, I'm sure there's something we can do with that, so that this no longer controls this motor. It will control an Arduino or of some kind. A Nano probably would fit in here very well. If you look down the end, it's just got a battery holder down the back. So I bet you're really eager to find out how it all works. Yeah. Now follow me on this then. So I've taken this bit off, right? Okay, so we know what's going to happen as soon as I flip this, but there's a little micro switch down here, which is interesting, and this changeover switch at the top here is in fact a dual pole, so double pole double throw they're called. Okay, and this is not a servo at all. I thought it was a servo initially, because after all we have two-way movement, don't we? It goes up and then it comes back. Nothing so expensive as a servo. This is just a simple motor. So let's just have one more look. Look what happens here on the micro switch. So it goes whizzing up, clicks it over, comes back, and then bounces on this micro switch. So after a bit of reverse engineering, I have actually come up with the circuit diagram. And at rest, this is exactly what it looks like. So with my trusty pointer, what we can say is we have a double pole double throw switch here, which are ganged. That's what the dotted lines means. It means you can't move one of these without the other one moving as well. And yes, I have drawn these slightly odd. They should really be facing the same way, but having drawn them this way, I think it will be okay for a demo. So the motor is connected at rest in the following way. The plus of the motor is connected, in fact, to the ground. The negative of the motor is connected to the micro switch through this switch here, but the micro switch at the moment is open. This is normally closed, but we're actually, when that little arm comes down, it basically pushes this switch open. So that's this little switch at the back. So with the arm down in resting place like that, that switch is open because we're not using the center contact, it's just this outside contact. So what that means, of course, we've broken the circuit, which means this motor isn't connected to anything at this point, which is why it stops, funnily enough. Now, when I flip the main toggle switch, so this bit here goes to here, and this bit here goes to here, we can see that the motor is being driven then by the plus and by the minus. It's just a straight flow of current through that motor. Okay, let's move on to the next bit of the diagram then. So here we are. This is what it's like when it's running. So we've flipped it now. That one goes to plus, that one goes to ground or negative. So the motor runs. There's nothing to stop it running. However, this is where the clever bit works. As soon as it starts running, so on here, as soon as this leaves its resting place, this little micro switch obviously opens and it makes this contact here. So at the moment it's not joined, okay, the outside two terminals. But as soon as this leaves the resting place, this moves up and these close. So in here, this micro switch closes at this point. Okay, so this is now starting to run. Imagine this in very slow motion. We've flipped the switch. The motor starts to run. This little fingery thing starts to move, but only, you know, a centimetre or so. That's enough, though, for this switch to close, which does nothing in itself, because obviously nothing's connected to this side of the micro switch on that double pole throw switch. But the finger comes round and immediately knocks it back into a resting state. So basically like that. But with this still shut. So this moves to here, this moves to here, which effectively reverses the polarity on here, so the motor stops and goes backwards, which is why the finger then goes in the opposite direction, having knocked this round. And the reason it keeps running backwards is because this is shut. So this is ground, this goes to positive via the micro switch, so it just runs. And eventually, when that finger goes back far enough, it will touch that micro switch, knock it so that it is open, like that, and stop. I've paused there dramatically for, I don't know, a mental round of applause that I've reverse engineered this highly complex switching arrangement. Well, it is clever, isn't it? I mean, there's no getting around it. It's a clever little arrangement that they've done here, and quite well implemented, to be quite honest. So yeah, so that's that. I mean, I'll put that, just a picture of that. Do you know, if I were a professor or lecturer, neither of which I am, this would be a really good project to give to students and say, well, first of all, come up with this, right? And secondly, build this and make it work without giving them all the bits, of course. See how they come up to make it stop when it reaches a certain position. I'll do it again. Now what I'm going to do, I'm doing this again now like this, but I'm going to try and slow this down in the video so that it goes slow motion, and you'll be able to see it in probably more detail. So here we go. Because it's very quick, isn't it? Very quick. Once more. Now, of course, the first enhancement you could do to this, and the first one I'd do, is to slow the whole thing down. So here's a little example, right? I don't want to get bogged down too much into all the sort of nitty-gritty about how this works. That can be for a future video. But I've got an Arduino Uno at the back there, connected up to this H-bridge driver. What's an H-bridge driver, you say? It's something for another video. And there's the original switch and motor and all the rest of it. A couple of LEDs here that I was using just for testing. Now, to add value to this so-called useless box, what I've done is, one, put a delay on here, and secondly, just added a bit of sound, just to, I don't know, add a bit of interest. So if I flick it now, oh, it's going to fall over. Now you can hear the bleeping, it's getting quicker, so it sounds a little bit more urgent. And that's it, over and done with. So that's a very simple little example of what we can do. Well, all right, you know, there's a bit of faffing about, and I did draw out a few circuits. Let me get them here. So first of all, as you can see, I said, right, the first thing I discovered, which was really useful actually, if we just disconnected the motor from those points where it's connected onto that board, this switch arrangement, including the micro switch, could still be used as it is, without any cutting of wires or anything, as the signal for the Arduino. Right, we'll go into that in more detail. And here, I thought, well, can I do it with relays instead of an H-bridge? And the answer is no, because then we'd need a micro switch over here, not over here, and it was all getting too complicated. So I thought, right, blow that for a game of soldiers. Let's just do it properly, because I had an H-bridge. In fact, normally an H-bridge module might look something like this. This is a fairly common one, an L298 is that, I think. Very easy to use, but it's a bit clunky, isn't it? They're all dual motors, by the way. Obviously on an axle or something you can have left and right wheels or left and right arm. So they will control two motors with two wires, and then you just control what happens on the input here. But this is all a bit big and clunky. I did get it out to try it, but then I thought, oh, hang on, I've got one of these little tiny ones now. We have a working example. Let's do it again, because it's so pleasing, that grating beeping, isn't it? The beeper's off camera, actually. That's my little beeper. Basically, what this is, in case you're not aware of what a piezo beeper is, it's one of these. So it's one of these little tiny flat plates with two wires in it, just like that, and you put a square wave into it. It won't make any sound by itself. It must be a modulated square wave, at audio frequency. Now if I was to do just square wave into that, you wouldn't hear anything. It must vibrate against something. So normally you'd stick it on, say, a project, inside of a project, thing like that. So you'd hold it down nice and tight, put a couple of blobs of glue either side, and then it'll vibrate against the base. But of course, if you buy them like this, they're all contained and somehow mounted against a bit of plastic, and this is a vibrating echo chamber, which makes it sound a lot louder than what it really is. Right, there we are then. That's adding value to what would otherwise be a pretty useless box, but in fact this is getting more and more useful the more we add into it like this, and I haven't anywhere near finished yet. So there we are. That's just food for thought, and we'll go into some of this in a bit more detail sometime in the future when I've had a bit of a break from this. But good ideas, I hope, are coming your way. Right, I think that just about covers it today. So thanks very much for watching. And from me and Benny, he's behind me. There he is. Look on the front back. It's thanks very much for watching, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.